In this lesson, we're going to use what we know about proportional relationships and apply it to simple interest problems. Read the problem below, then explore different ways to understand how you can solve problems involving simple interest. Joshua borrows $300 from his older sister to buy a bike. He promises to pay the total amount plus 5% simple interest in 1 year. How much will Joshua pay back in all? So this problem says that Joshua is borrowing $300, but he has said he will pay back the total plus 5%. So let's look at some ways that we can model this. The first way that we can model this situation is with a bar diagram. And this bar diagram shows the relationship between the amount borrowed, the interest, and the amount to be paid back. So let's highlight that. It's going to show the amount borrowed, so he borrowed the $300, the interest, so the 5%, and then the total amount that he must pay back. So when we look at this, we can see that the diagram shows the amount borrowed plus the amount of simple interest paid. So that's going to be at the bottom, these two boxes, the amount borrowed and the simple interest. So those two together equal your total amount to pay back. So he's not just paying back a total of the $300, but the $300 plus that 5%. So remember, this whole top bar represents 100% of what he's going to pay back. And then we can break it apart into two parts. He's going to pay back the amount he borrowed plus 5% of that amount he borrowed. So another way that we can model this same situation is with an equation. Remember, this is a really important thing to be able to do. Writing an equation to find the total amount he's going to pay back. You can write the equation in words and then fill in the numbers you write. Write the percent as a decimal. So you can see, similar to the bar diagram above, the amount borrowed and the amount of interest added together, adding those two together, gives you the total amount he's going to pay back. So just like with that bar diagram we looked at above, the amount borrowed and then the simple interest added together gave us that total bar going all the way across. And we know from the problem that the amount that he borrowed is $300 plus, so we don't know the amount of interest, but we do know that it's going to be 5%. And we can write 5% as 0.05. So 5% of 300. So we don't know the exact amount of interest, but we know that we can calculate that by multiplying 5% times 300, because that 300 is the amount he borrowed. So those two added together give us our total amount that he's going to pay back. So that would be the equation, 300 plus 0.05 times 300 equals the total amount that he's going to pay back. Well, then again, another way that we can model it is with a percent tape diagram. And this is similar to the bar diagram at the top. And this is where we really start using our proportions to help us model it. So let's take a look at the percent tape diagram. So if you notice that the diagram both starts at $0 and 0%. And then as you move along the diagram, 100% lines up with 300. So again, that's the amount. 300 is the amount that he borrows. So he's borrowing 100%, $300, but then he has to pay back a little bit more. So that's where you get the 105. So remember, he's paying back 5%. So that's why it's 105. 100 plus 5 is 105. So this blue part of our tape diagram helps us model that extra amount that he's going to have to pay back. So he has to pay back 100% of what he borrowed plus a little bit more. So he's paying back a total of 105%. Now the way that we can write this with a proportion, you see that they've already written it as a proportion for us down here at the bottom. So 300 and 100% go in one ratio together, because remember those were lined up on the tape diagram, and that's set equal to another proportion, our cost over the 105% from our tape diagram. But then remember, we don't know that total amount to pay back, so we use the letter T. So this is an example of how we can set up a proportion and solve it to figure out how much we would pay back. And we'll look a little bit more in depth at solving that in a few minutes. Let's take a look at our next page and answer a few questions to help us understand more these diagrams. Number 2 wants us to look at the bar diagram. So that very first model it. What term refers to the amount Joshua has to pay back in addition to the $300 he borrows? So remember, he has to borrow $300 and then he's paying back a little bit more. So we want to know what term, so almost like a vocabulary word, represents that extra that he has to pay back. That extra is called the interest. So that extra he's paying back is the interest. What is the interest rate in the bar diagram? So we're still looking at the bar diagram. So referring back to that bar diagram and finding our interest rate. So our rate is going to be as a percentage. We can see that that interest rate is 5%. And we want to then see how is the interest rate expressed in an equation. So we want to look at that next model it, and taking a look at the equation, how is that interest rate expressed? They don't say 5% in the equation. What have they done? Well, they have changed it to a decimal. And we know that 5% as a decimal is 0.05. Next, let's look at the equation a little bit more. So in the equation, what does each number in the expression 500ths times 300 represent? So there's two things in this expression. The first one is the 500ths. What does that 500ths in that expression represent? Well, we just talked about it. The 500ths represents the interest. Or the interest rate, we should say. Then it wants to know, well, what does that 300 represent? The 300 represents the amount borrowed. Remember, he's not paying back 300. He borrowed 300 and he has to pay a little bit more back. Number 5, show how to find how much interest Joshua pays in 1 year. So this is where we want to actually do the math of finding 5% of 300. And remember, that word of means to multiply, and in order to do that, we need to use the decimal form of that 5%. and we're not using a calculator, so we'll need to go to the side of our paper and multiply 300 times 5/100. 5 times 0 is 0, 5 times 0 is 0, and 5 times 3 is 15. And then, because my other number is 0, I don't have to go through the steps of multiplying that because it's not going to change anything. But I do need to move my decimal. So the first number, 300, has no decimal places. But my second number has 2 decimal places. So I need to move my decimal 2 places, which would give us 15. So 5/100, 0.05 times 300 equals $15. And again, this is a skill that you need to be able to do by hand without a calculator. So Joshua has to pay back in interest. So this isn't how much he's paying back. This is how much in interest he's paying back, $15 extra. Next, we want to show how to find the total amount he's going to pay back in 1 year, including that interest. So remember, he borrowed. How much did he borrow to begin with? He borrowed $300. Plus, he has to pay back that interest. Well, we just calculated in number 5 the amount of interest. So plus $15. And those two together give us a total of $315 that he will need to pay back by the end of the year. So now that we've looked at the bar diagram and the equation model, let's look a little bit at the tape diagram. Because remember, this is where we start putting together what we know about proportions. So in the tape diagram, how can you solve this equation? And then what is easier to solve? This equation or the equation from the previous modelet? So remember, the equation in the tape diagram was setting up a proportion. So in the tape diagram, we had the proportion 300 over 100, because $300 was 100% of what he borrowed, equals T over 105. Because we don't know the total he's going to pay back, but we do know it's 105% because he's paying back 100% plus 5%. So you might ask, how would I solve this type of equation? Because this equation looks very different than equations that we have seen before. So in order to solve this type of equation, so this is a proportion equation, what you want to do is cross multiply and then divide. And the direction you cross multiply can be different depending on how the problem is set up. But you always want to cross multiply your two diagonal numbers that match up. So for this one, we would cross multiply 300 times 105. And then take that product and divide by 100. So when you're solving a proportional equation, you always cross multiply and divide. So when we look at this, we would need to multiply 300 times 105. So we would need to do that on the side of our paper. 105 times 300. And if you don't know, there's a little trick. If you're multiplying by a multiple of 10, you can just push that number over like I did on the side with my 300. So 3 times 5 is 15. 3 times 0 plus 1 is 1. And 3 times 1 is 3. And then bring down your zeros. So 300 times 105 is 31,500. And then we want to take that and divide by 100. And another trick here, so you don't have to do that long division, since they're both multiples of 10, you can kind of see where your zeros line up, and you can cancel those zeros out. And so you're just left with 315 over 1, which equals 315. So when we cross multiply and divide, you see you get the same thing of he's going to have to pay back $315. So now that we know how to solve that proportional equation, which is easier to solve, this equation or the previous equation? So this might just be a personal choice as to which one was easier, and sometimes one method might be easier than another method. So you might reflect on this question and say you like the proportional relationship because you didn't have to deal with that decimal. Or maybe you like the decimal method equation better because you didn't have to deal with such big numbers. But either way is okay to solve it. We do want to make sure we know how to solve it both ways. And we'll be practicing the proportional equation way more and more as the year goes on. Number 8 asks you to describe how to find the total amount to pay on a loan when paying simple interest. So for number 8, I want you to pause the video and I want you to write in your own words. I don't want you to use any numbers from the problems we've talked about. Using your own words, I want you to describe how to find the total amount on a loan when paying simple interest. Go ahead and pause the video and write your thoughts down. So there's two ways that we talked about that you could have described. The first way was with that first equation. So you could multiply the interest rate times the amount borrowed, and then add it to, so you're going to then add that product to the amount borrowed. Because remember, you're paying a little bit more than what you actually borrowed, so that's why we're adding it to it. And then the other way we looked at was with the proportion. So you could set up a proportion then cross multiply and divide. And either way is fine, but then again, like I said, you need to know how to solve them in both ways. Sometimes you have the option to choose which way you would like to solve it, whether it's with the equation or setting up a proportion. And then sometimes you might be asked to use a specific way. Take a look at the triads. They say, use what you just learned about simple interest to solve these problems. Show your work on a separate sheet of paper. If you have room on the side of your paper, feel free to show your work there. What I want you to do is go ahead and highlight number 9 and 10. And then I want you to solve these two. I want you to solve one by using the equation, and then solve the other one by setting up a proportion. And you can choose which one you solve either way. Go ahead and pause the video and solve those, making sure one is solved with an equation and the other is solved by setting up a proportion. Number 9 wants to know how much will she pay back if she pays the full amount in 1 year. So she borrowed $720 and she paid 8% interest. She would end up paying back $777.60. That's the amount she borrowed plus the interest. Number 10, if he does not deposit or withdraw any money, how much will he have altogether after 1 year? So 1.5% and $400. So he has $400 in the account, and 1.5% interest is what he earned. So he's earning money as it's sitting there. So we're still going to be adding it to it like the other problems, and he would earn a total of $406. So what he originally had in there plus that $6. If you need to see these two problems worked out either by an equation or setting up a proportion, please reach out to me and let me know.